Earth Observation or EO Browser is a dynamic online platform developed by Time-Lapse where one can access several satellite imagery data sources and even perform basic post-processing and analytics on the fly. We will do just so and create a time-lapse which will allow us to see how a shoreline is developed over a period of time. You'll need to sign up for a free account on the portal in order to use the time-lapse feature. Let me show you the area of interest on Google Maps first. It lies on the southeastern coast of India in the metropolis of Chennai. On the satellite imagery view, let me zoom into the Marina beach, which is India's longest beach. This is how it looks. In particular, we will be keen to observe how the shoreline has evolved on the southern section of the beach. This portion lies on the confluence of the Adyar river, which deposits itself onto the Bay of Bengal. Back to the EO browser, we will select Sentinel-2 imagery as our data source. Operated by European Space Agency, this multispectral satellite constellation has a few distinct advantages. It is free of cost to use, has a wide geographic coverage, a high revisit time, as well as a high spatial resolution for Earth observation purposes. On the EO browser, we will type in Marina Beach on the Go to Place box. One advantage of this platform is one doesn't need to input coordinates or input the WKT file to select the area of interest. Just by typing out in the search box, we can basically find satellite imagery for that particular section. We'll select a period of 1 month from March to April 2024. We've already selected Sentinel-2. And we'll now hit the search button. The search results pop up with all the details. We will visualize one product. We now get the option to do a basic level of post-processing. So for example, false color demarcates area of natural vegetation very clearly. So on the fly, the imagery is processed and one can see the red section is vegetation. But we'll be interested to do NDWI, which is normalized difference of water index. In this particular, you can say modification of bands, what happens is the water features are clearly demarcated, as you can see. Now we will create a satellite imagery time lapse by clicking on that particular button on the right. So now it's very easy function to use. The particular area of interest, as I told you, is on the southern section of the beach, and this is where we'll center the, you can say, the particular box onto. Next, what we will do is go click the play button. A new section of the page opens up. In this, we have several options to choose from. One particular option which we'll have to take care of is we'll need to have a very low cloud coverage, because we don't want clouds to basically, because it's an optical imagery, we don't want clouds to interrupt our, you can say, obstruct our findings. Now, the L2A product of Sentinel-2 is typically available from 2017 onwards. So we'll select 2017 to 2024 as our time period and hit the search button. All the search options are loaded, and on the right hand side at the bottom you can see that there are a sum total of 39 products which have been loaded. Now all these products are sorted on a monthly basis, as you can see on the top left section. So on each month, if the cloud cover matches, it shows a particular product. And now once we hit the play button, we can see how the satellite imagery has evolved. And you can see that on some sections, the Adyar river finds an outlet into the sea, whereas in some time their passage is blocked by the, you can say, beach. And the timeline is also shown on the top right section of the media which is being played on the browser. Isn't this a very cool feature? You can see one of the distinct advantages over Google Maps is, while the imagery on Google Maps is intermittent, but with Sentinel-2 you can find a very, you can say, frequent sources of satellite imagery. Now one particular reason why we selected this area of interest is because it was observed that there is accretion which takes place on the southern section of the beach. Now, typically, coastline erosion is treated as you can say, an adverse effect, but then accretion is also sometimes an adverse effect, because what happens is the Adia river doesn't find an outlet into the sea, and basically the pollutants also stay back in the river instead of depositing it to the sea. So this is one of the reasons why we were keen to observe this particular area of interest. Now, while we had observed the NDWI, you can say playlist, we can also select another form of playlist. So this is your, you can say, true color, image, which looks like a normal photograph, optical photograph. And we can also, you can say, play around with the frames per second, etc. And we can see how the imagery has observed over this period of time which we had selected. We also have the option to download the imagery as a GIF file. And it's a very quick procedure. And while you can say we are not performing any high level technical analysis, but it definitely gives a very, very good context and much better than your Google Earth in order to see how the Marina beach has evolved. However, let me tell you that in Google Earth, because the imagery resolution is high, so for particular beaches, that is only preferable.